Today's class will be a quick one. We are looking at relative density. This is listed, in the Cambridge curriculum. But I want to say here that relative density, as far as physics is concerned, is listed in other curricula as well. Now, the key thing here is relative. We have a relative density of any substance is the ratio of its density to that of water. Hence, it has no units. So, relative density has no units. It's just a numerical constant. That's what you have because you are comparing or you are dividing, similar quantities. So, for relative density, for us to really get what we need to recall that density of any substance, is always mass of that substance divided by what? The volume of that substance. Okay, so like I said here, relative density is the ratio of the density of that substance to that of water. So if we are looking at the relative density of any substance, we don't know what the substance will be. Let's call it subscript S. Okay, so we are looking at the density of that substance divided by what? The density of water from the definition here. But recall here from this equation, density is always mass over volume. So if we put mass over volume, we replace whatever densities we have in these fractions with the ratio of mass to volume. Okay, so that means for the substance we will have rather mass of that substance. Okay, whatever it is, we have mass of that substance divided by what? Volume of that substance. We still bring our division bar, and then mass of water, are you there, divided by what? Volume of water. Now whenever you have a fractional denominator and it was division as your operation, you change from division to multiplication, your elementary mathematics. So the numerator will still stay. We are not going to touch that. So we would rather have a mass of that substance will stay, the numerical ratio, volume of that substance will stay, and then we bring in multiplication sign. When we introduce multiplication sign in place of division, we are taking the reciprocal of the fractional denominator or the multiplicative inverse. Just turn it upside down. That's all. So we'll have volume of what? Water divided by what? Mass of what? Water. Now we are looking for a way to have relative density, as a ratio of masses. The only way volume of the substance and volume of water will cancel out is if they are equal. You see, so if volume of the substance equals volume of water, definitely these fractions, they will simply cancel off because we are looking at similar quantities. So that way we can go ahead and have that mass of the substance, okay, divided by what? Mass of water. Are we there? Defines relative density. But when you define relative density, as a ratio of masses, you must specifically state equal volume. So relative density can also be defined as the ratio of mass of a substance to mass of an equal volume of water. That's the end of the class. In case you've not clicked the follow button yet, do so. And if you've not enrolled for our holiday classes, do so. Take care.